bakalım.
So, good afternoon, everyone. I am Edmondo Occhipinti, and I am the director and founder of 3IM. 3IM is a consulting company that specializes in providing business process design services and implementations, including building information modeling. And I'm going to start today the American way. So I'm just going to start introducing myself very briefly.
Sorry.
Sure. So I was going to say that I was just introduce myself very quickly. I have more than 10 years of experience in the industry of architects, engineers, construction companies, and owners and operators. And I've been spending the past 15 years focusing and researching, implementing and designing 3D and virtual technologies for construction. I've been working in more than 50 projects that successfully implemented and used building information modeling, and I've done this across the world in more than 10 countries, including United States, Brazil, Mexico, Italy, France, Germany, Middle East, and China as well. These are some of the projects that I've been working on. It's like really a very selection of few. The World Trade Center in New York is the first one. The Yas Island and the Formula One circuit in Abu Dhabi. The Metro 12 line with the tunnels in Mexico City. The Louis Vuitton Foundation in Paris. And then the Qatar National Museum in Doha, the Cleveland Clinic in Doha. Again, just like a very small selection of projects. So I was invited today to talk about sustainability and building information modeling. What I'm going to talk about is what's the challenge in the construction industry that we are all facing, and what are the problems that are characteristic of our particular industry, and what are some of the solutions that could help address the problems that we are facing today in order to achieve the objective and making it for the challenge. The problem, this is like one of the major things, and I think we should all put that much attention in this for few numbers that I'm presenting, and this is that 10 to 15% of material in construction today is wasted. And we are talking of a $3 trillion US dollars industry around the world. That means a huge amount of money goes into waste every year. That 30% of the construction work is actually rework due to mistakes that we have done before, and that almost half of the main power that we use in construction site is actually wasted because of improper communication to the staff, because of unclear planning of operations. And the last two, I think they're very scary. 90% of mega projects are all the projects above $100 million, run at an average of 28% over budget. That means that if you today are gonna build a project that is budgeted 100 million, you're actually gonna pay 128 millions. And it is a huge gap there. And almost one every two projects in the construction industry experience delays and runs over budget. This is a serious problem, but the good news there is that we cannot go any lower. There is nowhere to go than up. So what we can actually do to do that? When I was invited to talk about sustainability, I guess that sustainability in this particular context means addressing three main things, which is, remember the numbers that I showed before, reducing the waste that is still extremely high, and increasing the efficiency and the productivity of the way that we build. That means increasing the productivity and efficiency of the construction process. And so at the end also improving the quality of the buildings that we deliver. Bear in mind that in the entire cost of a building, 10% is construction and 90% is actually the cost to own and operating that building. That means if we deliver better buildings, we could actually address some of that waste in the phase afters. So how do we do that? In order to get there, I want to step back a little bit and share with you a couple of thoughts around the inefficiency in the construction industry. And I always love to share this image. This is one of the construction sites where I was 3 or 4 years ago is the Cleveland Clinic in Abu Dhabi. And the reason why I love this image is that shows how many things happen in a construction site at the same time. There are equipments, there are machines, there are materials, there are people, and all these things, they need to interact all together in order to build up the final building, and that final building actually has to work. So why I love this? Because if I would step back and I wouldn't think that I belong to this industry, I would ask, okay, how do you do that? And the scary answer is that we actually build and we manage that complexity with this type of documents, which means these are thousands of drawings that gets transmitted to the construction industry that are extremely dense of information, and they're all, let's say, inconsistent with each other, and they bring a lot of work of reinterpretation. And you know that when you deal with interpretation of the stuff, you're basically dealing with potential mistakes. So, you know, I wouldn't be surprised in general if, you know, even if we go in some of these, let's say, exaggerations, that the information that actually exists in those drawings is very inefficient and brings to a huge misunderstanding in the construction side. So back 15 years ago, when I started, me with colleagues and other people around the world, we started thinking what is actually the best way to communicate information not only in the design, but through the entire life cycle of a building. When we start the concept design, when we develop a project, when they transmit the project to the construction companies, and when they deliver the building. And so I've been spending the 15 past years designing and implementing systems that allow to centralize the whole information in one single source that is in 3D, and so better manageable in terms of information and extraction of that information. So that's actually what we do for work. We design those processes that enable our clients, the architects, construction companies, real estate developers, to improve the productivity of their constructions. And the way that we do that, if you can click on this project, please. The way that we do that is through some operations, and I'm going to present one example. I have like very short time, so I'm just going to present one example, which is the One Island East in Hong Kong, where the client was actually a real estate developer that started implementing this process in this particular project, and then after this one, gathering very exciting results, went for other 7 projects with us, and now today just builds naturally just using building information modeling. Just a couple of numbers. By the implementation of the systems that I'm going to present to you today in this project that is actually pretty old, it's from 2007, we were able to save 43 days of construction and reducing, and those are the client metrics, 15% of the construction cost. How did we do that? Again, I'm going to present you very shortly here, but we basically replaced the idea of having 1,000 of drawings or inconsistencies by just one source of model that was also informed by every single actor in the project. So the facade consultants, the MEP consultants, the architects, the local architects, the pre-constructions, they were all contributing in creating, this big model with the all information that would be useful for the design and for the construction after. So all these people were actually interacting and supervised by the client, Swire Properties, and all creating 3D information in order to streamline the design process and the construction. This is also possible because behind this there is also work that we had done to start crafting contract language and clauses in the contracts that enable people, not oblige is a bad word, but enable people to interact in a new manner of working, which today is most known as integrated project delivery, and that actually also talks about the way that 3D can actually be contractually used for the construction. So we started from scratch. No one of those people that worked in 3D, so we start training all the different people in 3D, and they all were able to start creating the first models. And so also all the quantities, in this case all the quantities of the concrete were automatically extracted from the model on a regular basis every 2 or 3 weeks. And that also give us a very clear picture of the impact that every design change would have on costs and on quantities. And at the same time, all the 2D representations of the building were also extracted from the 3D, avoiding then all the mistakes that are typical in a process where you have to draw by hand every single drawing in 2D. But most importantly, one of the other things was that by enabling everyone to work in 3D, we were actually able to get a full sense of what was going on in all the different trades. So in this case, for example, we were checking if there was any inconsistency between the data provided by the MEP consultants and the one provided by the structural engineers to make sure that there was no interference between the two trades. And this type of coordination was actually done on a weekly basis through video conferences in physical places like the one in picture, where there was this coordination going on in 3D, and we could address specific problems and trying to get an answer not immediately, but in the next few days, in order again to increase the speed of the decisions, but also of the right decisions. And at the same time, all this information was brought into the construction site to clarify every single aspect of the project that may have been unclear through the normal process of transmitting to the drawing. So in this particular case, the engineers of Gammon, they're trying to solve a specific problem that arose from the plans, and so they're trying to see in 3D what type of solutions they can address. But I guess there is a video here, if it can be launched. A lot of the work was also in trying to understand, before getting in construction, what was every single process of a construction was going to look like, in order to optimize it as much as possible and to avoid any potential conflicts in the construction. There would have been a lot of money more. So in this particular case, in this sequence that I extracted from this video, is because in this particular case, according to the schedule, we had found a problem of interference between the table formwork and the column formwork. So in this case, we would have had to plan that an additional crane should have been free to come there, getting that element out, and then finalizing the operations. But again, all these things were actually happening 6 to 8 months before the construction. That means that this particular type of operations were actually resolving problems that could have happened after. So again, if we look at the numbers that I shared with you before, those 43 days of construction saved, those costing savings, they all come from these particular studies that were run way before we actually found ourselves in the construction site. And then, as you see, 6 or 8 months later, that's exactly the way that the construction site was looking like. So you also get the feeling that you get in the construction with a lot more confidence to carry the work forward. I guess there is another video here. Well, can you go back one? Yeah. Anyway, we can skip it. We talked about this one. So all this type of things were also possible because we were actually linking the 3D model with the project schedule in Microsoft Project, I guess, was that time. And so we could actually then go in very detail in every single operations of concrete pouring, like in this one, and optimizing the sequence of the construction. In this particular case, I guess, you cannot see, but there is a simulation by day, so by day and by hour. So we are seeing what's happening on this particular operations of the concrete pouring on day 1 from 6 to 7, from 7 to 8, and so on. And so again, all these way before the construction. And these enables you to see things that you wouldn't be able to see before in any other way than this particular one. And it's also like in extremely detailed, so that allows you to optimize every single operations and to basically cut that safety percentage that you always apply on the schedule. So in this particular case, we could actually be very tight and be extremely efficient and effective on the concrete pouring. let's see if this one starts again. Yeah. So once all this information exists, it doesn't die there. Yeah, we have been talking about life cycle of the building. This was one of the first buildings that actually start using the 3D model. This is just one floor of the 75 on the tower. That is on a decent level of detail, enough at least to run the facility management directly from, kind of directly from the model. So this model was actually used as a base to understand the as-built conditions of the building and know exactly where some of the systems were built and their sequence, so that you could actually schedule maintenance and operations in a much effective way, in a much quicker way. Yes, in this case I think we're going to see the exhaust from the toilets, but to see that if you had to intervene, you know exactly where to go by using directly the 3D model and not like to go look for 1,000 of drawings behind and see where you can find the information that you need. So yeah, now I'm just going to show you a couple of images between like the virtual model and the real model. And again, there was always this back and forth between the 3D model, the quantities, so all the different tons of steel that were used. Some of the steel was actually CNC cut directly through the CNC export from the 3D model. And also the quantities of the concrete and the facade as well, as you can see in one of the details here, and then the actual assembly of the facade on site. And then again, like in order to bring more efficiency in the construction, in this particular case, what you see is that the MEP installers, they were actually plotting points from the 3D model into the ceilings with the yellow tape, so that they knew exactly where to put their ducts, and so that also the assembly part of it would have been error-free. And again, also it's worth to mention that the MEP in this particular case were also CNC cut through the developed surfaces of the MEP model in 3D. So the entire process was extremely streamlined, and again, this is one of the ways that you can actually get to those metrics, reducing time of construction, reducing or controlling the cost, and definitely managing the risk for the owner. That again, very excited from the results that he got in this particular project. Then he was also able to going forward with 7 more projects using our help, and then by itself today, where he actually builds every project with using building information modeling and manage the assets and the facilities through 3D. So again, I don't have a lot of time today, so I'm just going to show you one of the videos that you basically, unfortunately, you're going to see myself again in the video, but I hope that I'm going to look better there than here, and yeah, just leave you with the video for a little bit.
Years ago, people were very reluctant to shifting from the drafting table to the first CAD systems, and today every single project uses CAD and 3D representations. We are at the beginning of a deep transformation of the construction industry that is really going to have a great impact on the way that we design buildings, on the way that we deliver them. Through the use of building information modeling, today we're able to centralize all the building information in one virtual mock-up in 3D, and from there we are able to control every single aspect of the project before it gets in construction. What is the best way that we can actually communicate the design intent to the construction company to achieve the perfect result in terms of product of delivery? You know, from in one side we had, you know, the traditional delivery, which is, you know, a pile of plans design. And on the other side, we start considering of putting all this information together and federating this in just one consistent source of information, which was represented in 3D, so closer to the common sense of understanding reality. Using 4D simulations and construction sequencing, not only we are getting a sense of all the operations during the construction schedule, but we can also go in very detail in one particular operation in trying to simulate every single step that needs to be achieved in order to perform the whole activity on time and with the right equipment. Things like crane operation, staff training, safety, material layout, all these things can be studied in 3D and resolved way before we get in the construction site, avoiding any potential problem or unexpected scenario, and also bringing savings in time and money. More and more facade subcontractors and steel manufacturers are using numeric control machines to produce their products. This enables us to use the information directly from the 3D model and passing it to their machines to streamline the manufacturing process and avoiding loss of information and data that is typical of shop drawings and 2D representations. So we're using the most advanced technologies in 3D to design, visualize these connections and actually transfer the information from these 3D components directly to the manufacturing machines for the steel production. I think we're opening new scenarios in the way that users can actually interact with their space, both physically and virtually. Throughout the years, we had some of the most renowned architects in the world to get the visions built, and we want to apply the result of that experience to get all projects today built on time, on budget, and with 100% quality.
Okay, that was it. I know that I really didn't get like much time today, but if you get any questions or any doubt, or if you want to learn more about all these, I'm sure that we can catch up later or somewhere. So thank you very much for your attention, and also thank you for inviting me here to share with you today. Thank you.